Hi, gents. Welcome back over Easter. Hope you had a good rest inside that time. Thank you for the emails that you've been sending me good questions to do. So I'm gonna start making a little series of those questions and just do them out. So this one's gonna be the first one. Um, I don't know if we should address the fact that the leaving cert's been pushed back. I think that's in some ways unfortunate for you. Uh, I am surprised that it's not being done in June because I don't see anything that says that the end of July is guaranteed to be better than June. I would have thought doing it after a lockdown would be a good idea, but anyway, that's sort of the way it is. It does give you lots more time to practice your maths, I guess, because there's nothing else to do. But look, I will help you as much as what I can, including during the summer and that sort of thing. You can send me stuff, and we'll do our best to be as good as what we can. Here's our first question. Find the coefficient of the term independent of x in the expansion. So this one here, it's testing two things. It's testing, do you understand the words, the language that's being used, and do you know Pascal's triangle? So obviously they're both critically important things for life. Pascal, I have done out to the right hand side. You hopefully remember how to do that. Just a reminder that, for instance, if we were to take this line in here, that line there is actually made up of 1 is actually 8, choose 0. If you have 8 things and you want to choose none of them, there's one way to do that, you don't choose them. If you have 8 things and you want to choose one of them, you have 8 combinations. If you have 8 things and you want to choose 2 of them, there are 28 ways to do that, and so on and so forth. Okay, the very last one is 8, choose 8. If you have 8 things you want to choose all 8, it goes to 1. So that's where that line is coming from. And you know as well that it can then be applied down here. So this is just an example of the application of it. And what you have there in red is you've got all of the Pascal's triangle's numbers are all the coefficients of the different variables. This is called the binomial theorem. And it is actually in your tables book as well. It's right here, binomial theorem right there. And what you have is now this looks kind of complicated. We might actually just derive this for ourselves down here. What it says is a plus b to the power of n. Okay, so this is the like main template for it. We know that it always starts with a 1, but instead of just saying 1, what we can really say is that it is n choose 0. In the same way that this one over here, that's 8 choose 0, that's 7 choose 0, 6 choose 0. If you're on the nth row, it's n choose 0. And you will have a to the power of n, and you won't have any b's. You can say b to the 0 if you want. Plus, then it'll be n choose 1. So that one's 8 choose 1, 7 choose 1, 6 choose 1, etc. So that's all that we're doing there. I'll put those things back. 7 and 8. And it'll be a to the power of, now what happens, it was the power of n, it's now the power of n minus 1. So it went, for instance, here from 4 to 3 to 2. So you can see what's happening there. That power is going down. And it goes b to the power of 1. You can put a 1 in there if you want. Then it'll be n choose 2. And it'll be a to the power of n minus 2. That keeps going down. And this will be b squared, etc. Okay, dot, 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 dot. The very last one is going to be n choose n. Stop there. It'll be a to the power of 0. So a to the power of 0 is just 1. So you can put that in if you want. And it'll be b to the power of n. That's called the binomial theorem. And there it is. Okay. And if you want to know any particular term in there, you can just use this one in here. Okay, so if you wanted to, if you had, for instance, 10 choose 6, in there. Now, how would this thing work? That would mean that if it's something to the power of 10, but you want to go and get what is the 6th or 7th term, depending on if you count that as the first or the second or the third, this will just tell you how to get it. Okay, so if you wanted to move in to really what is the 7th term, you would have to use, sorry, if you wanted to move into the 6th term, I beg your pardon, you would have to use, no, it is the 7th term, sorry, you would have to use or as being 6 here in that case, okay, because that's the first term inside there, that's the second, that's the third, etc. So you would just plop it inside there. Okay, let's get back to it. What does the question mean? Find the coefficient of the term independent of x. It just means when you multiply this thing out, which is going to be the number that you get. What I mean by that is when you multiply it out, you'll have, for instance, x to the power of 8, something x to the power of 7, you won't actually, but something x to the power of 6, and so on, which is the one that has x to the power of 0, or is just a number. It doesn't have an x beside it, basically, as we go along. That's the way to think about it. So what we'll do here is we will just go and use our little formula here, our template, a plus b to the power of 8. We're using that bottom row of Pascal's triangle. You can think of this as a choose 0, or you can just say 1, a to the 8, plus 8, that's a choose 1, and it's a to the 7b, plus 28, that's 8 choose 2, and it would be a to the 6b squared, plus 56 a to the 5b cubed, etc. Okay, we'll do that. And we're going to apply to x plus 1 over x to the power of 8. Let's just see what we get. So we get 1 times a to the 8, so that's x to the 8. Okay, so that's simply x to the power of 8, plus 8 amounts of, now it's going to be x, and that's going to be to the power of 7. I just put that 8 over there just to make it clear. And then it'll be b to the power of 1, well, b in this case is 1 over x. So we end up with 8, and we get x to the 7 over x, or another way to say that is 8 x to the power of 6. We'll get 28, will be x to the power of 6, and 1 over x squared. So we get 28 x to the 6 over x squared, and you can see that that's 28 x to the power of 4. And you can already see what's happening here. Okay, this thing is going down in 2, so we might make a little educated guess that it's going to be 56 x squared, and then the all important one, it'll go 70 x to the power of 0, x to the power of 0 just being 1, so that's going to be the one that doesn't have an x in it. So it looks like the answer is 70. We'll just double check it. It's 56. It's x to the power of 4. And it's 1 over x cubed. So that's 56 x to the 4. That's over x cubed. So that is going to be an x. Did I do anything ridiculous? I did. Yeah, I did something ridiculous there. Sorry. Power of 5. So that does get us our 56x squared. And last but not least, 70, the all important one. X to the power of 4. 1 over x to the power of 4. There it goes. Cancels off. X to the 4 over x to the 4. So we're just left with 70. The next one would obviously be 56 x to the power of minus 2, or that's 56 over x squared, whichever way you want to think about it. Find the coefficient, find the number of the term which is independent of x. That number is 70. Okay, that's a good one. Might come up. There have been ones like it, and you should be pretty confident that you know how to use Pascal's theorem along with it. Okay, best of luck.